quick video to link it all together. So we dropped off with the wave speed by looking at a node and looking at what made that argument of that sine wave stay zero. And then by connecting Faraday's law and Ampere's law, starting with one magnetic field and ensuring that we end up with the same thing, we got this relationship between the wave speed and the material properties. I want to take that apart, and for electrical engineers, how do we remember the units of these things? We're talking about, for vacuum, we should be able to get the speed of light out of this. You can plug in these numbers and do it. 1 over mu naught epsilon naught square root should give us the speed of light. And so we have to get meters per second. Okay, 1 over something something henries per meter and farads per meter. So this is a good opportunity to review those kind of units. And we can do it using things we know and love from circuits class, where the voltage in an inductor is L di dt. We know the inductor units are henries. And for capacitors, C is defined as charge in coulombs over volts. Okay, so we've already got farads down, coulombs per volt. Henries, maybe a little bit less familiar, but the units of L are volts over, what's the units of di dt? Current is coulombs per second, and then you're taking a time derivative, so you're getting coulombs per second squared. And when you multiply henries and farads together, you're canceling out a lot of stuff, so you're getting seconds squared. Okay, and that's underneath here, so we're going to have seconds squared over meters squared. Flip it up, it looks like a speed. And I talked about the index of refraction being the ratio of the speed in vacuum versus the speed in a material. Okay, and speed in materials for common materials that we use every day is slower than in vacuum. So we have to flip these ratios around. And we've got the index of refraction. You can see how the index of refraction, since it's just a ratio between two different speeds, and here we've got permeabilities and permittivities, got the same units. It's just a constant. I mean, it's just a unitless quantity, a dimensionless number, index of refraction. Bonus segment at the end of this video. For those who try to plug it in and were paying attention, wait a second. You got to have this thing work out to be approximately 3 times 10 to the 8th meters per second. So we checked on this part, we check on this part.